Good morning, welcome to this new webinar focused on C&I solution. With me is Orysia Levchenko, Marketing Manager of Northern Europe in GoodWe Europe. Hello, good morning, Orysia.
Hi, good morning. Good morning, everyone. Welcome to today's webinar. I will be on the organized side from behalf. So if you do have any issues with the Zoom platform, you cannot see the presentation, just drop the message in the Q&A. I will try to help you. Thank you.
Thank you, Orysia. And also with us is David Havenga, technical manager, colleague of mine in technical team. Orysia is the commander of this platform, as he already mentioned. And I have to say that David is a master of energy management in GoodWe Europe, in the EMEA region, actually. It's a very good technical element, I would say. And it's a pleasure also to have him here supporting us in this webinar. David Havenga is a technical manager in South Africa and support us also in all topics related with energy management. Hello, good morning, David. Thank you for coming.
Hi, everyone. Thank you very much, Luis.
So I think we can start. Let me introduce the content that we are going to use. One second. Today we are going to be focusing those. I would say the first 4 chapters. Let's see if at the end we are able to have some time to see the SEMS portal. But in any case, we will have a look briefly as well. So the first point, the company intro, briefly. I think all of you know already GoodWe. The second point, part of the core of this webinar, is the C&I portfolio and key features of the portfolio. We will spend some time in key features that we understand that are the most critical ones for the commercial and industrial segment. The third point is the commissioning steps. You will see how easy is to do the commissioning, not only for internet, but also the grid setup. We will do some examples virtually. And the fourth chapter is a case study with the SEC1000 solution that we introduce here today for all of you, also including a brief introduction for the commissioning of this solution. This device is very common in C&I, especially in Europe, but not only there. So we will see more in details this solution. This, according to the market, or at least the output of the market is very positive. The feedback of the market is very positive about this solution that is, you will see, is very powerful in the way of the feature that provide only one device. So for those who don't know yet about GoodWe, we are an inverter manufacturer. I would say that we are not only an inverter manufacturer, we are a solution provider. You will see through this presentation that it's not only an inverter topic, it's a solution topic, right? What we are going to talk, especially with the SEC1000. In any case, to make it simple, we are an inverter manufacturer. We produce a string inverter. That means that we don't produce central inverters, and there is probably you know very well, there is a trend in the market that we move from central inverters to string inverter, even in utility scale. In that way, we introduced that this year the utility scale product. We will see in a few slides. And since the moment that we set up the company in 2010, during these 10 years already, we have been awarded with many milestones and many awards. For instance, just to mention some of them, the Tube Rheinland. I think everybody knows Tube Rheinland, independent certification entity, who organize every year a number of competition to qualify and to test first and to qualify the quality of the inverter depending on the segment. And GoodWe is the only one inverter manufacturer who already won in 6 consecutive years, right? This award. Recently we got this award as well of the EUPD Research. It's an independent institute as well in Europe, and that applies for all the world. About the quality and the quality of the brand in different markets, right? Like Australia, Netherlands, etc. For instance, just to give not only quality, but also from the analysis for consulting companies' point of view, also according to, also we have been ranked like a #1 in terms of energy expertise by McKinsey, like a #1 in 2019. And we have to update with the 2020. So this is only few of the awards. that recognize the quality of the product, the design, and the high performance of our solution. We are already more than 2,300 people. I have to say that at the end of last year, we were around 1,900 or close to 2,000, and we are getting bigger because the market is getting bigger, and we are successfully going to the market, right, in every product, in every market. In R&D, this is an amazing step forward. We were at the end of the last year around 230 people, more or less, and we are in the plan to get 500 at the end of the year. Actually, right now we are more. We have more than 400 R&D guys. Probably R&D is, I have to say, this is the most difficult profile for hiring, right? In a company, this has to be really focused, really dedicated, and so on. And we are achieving this a huge step forward for the company. And abroad of China, where we are based, we work more than 70 people, like Oricia, like David, like myself, that we work for GoodWe Europe. And an additional point we would like to mention is the global revenue. This is the trend that we follow. As you can see, the market recognize our work, our quality by means of the revenue. And also in 2020, we launched successfully the IPO of the company. We are a public company in the Shanghai stock market, which is also an additional point of transparency and our commitment to go to the market, right? In these 10 years, we have been deploy a number of teams from 2020, when the company was founded in China. In 2018, so quite recently, was founded GoodWe Europe, where we work, based in Germany, from where we manage Europe, Middle East, and Africa, the EMEA region. And what we do, as I mentioned before, we are an inverter manufacturer, but not only an inverter manufacturer. Let me highlight this. We are already a solution provider. We produce string inverters for what we call grid-tie inverters. We have 3 different families: residential from 700 watts to 15, C&I, that we are going to be focused from now on, from 70 to 136 kilowatt, and utility scale that I mentioned before. We introduced this year for this segment with our new HT series up to 250 kilowatt. The second line of the company, I would say that even if it's the first line, because we were focused from the beginning, from the moment that GoodWe was founded, we were focused in a storage solution with the ES and EM inverter. That's part of the hybrid family. And the second family of the storage inverter is the AC couple from up to 50, right now 50 kilowatt inverter that applies for C&I. We are not going to touch this topic today. We are going to be focused in C&I, but we will have time in following editions of webinars to also tackle this solution that is already on the market. And the third line that we launched this year is the battery storage that combines perfectly, as you can imagine, with our storage inverters, right? Battery in low voltage and high voltage models, and also the all-in-one solution that you can see here on image. And of course, the energy management and communication is a cross topic to the portfolio. And as I mentioned, the storage was one of our core, it is one of our core business, and that help us to develop better inverters and better all-in-one solutions. So the portfolio that we are going to see this webinar is the C&I, the commercial and industrial. We have here a resume. We start with the SDT Generation 2 with 2 MPP trackers, the models with 16, 20, and 25 kilowatt. We have also, let me open a bracket. We have the SDT Generation 2 also in the residential, comes from the 4 kilowatt to 15 kilowatt. And as you see, there is a perfect scale of the size of the inverters, and therefore of the scale of the PV size, PV system, right? So we come from the residential from 700 watts to up to 250 kilowatt. Probably the market will say that GoodWe is probably the inverter manufacturer who has the biggest portfolio and very well divided, well segmented, depending of the size of the solution that we need to, or you want to satisfy to your customer, right? So for the C&I portfolio, we start in 17. We have 20 and 25 kilowatt for the SDT generation 2. We come later on with the SMT series, 25, 30, 36, with 3 MPP trackers. Obviously, we are talking about 3-phase and 400 output. Then I think probably most of you know very well, not only SMT, but the MT series, quite common in EMEA region, with 50, 60, 70, 80 kilowatt, 3-phase and 4 MPP trackers. I mentioned here X, you can see here there are different output voltage, 400, 500, 540, depending on the model. And then this year we already, we launched it last year, but this year we already provided and setting up a number of projects with the HT series that is new in the market, with a model with 100, 120, and 136 kilowatt for the C&I. And I wanted to include here in this slide this column with the HT high voltage from the output is 250, and the output that you can see is 800 volts. This model is for the utility scale. A transformer need to be dedicated for this inverter or for that PV plant equipped with this inverter. And then, but I wanted to include it here because we get from more and more often from the market, from the EPCs like you, that this inverter is also attractive for C&I. No matter the output, it's becoming more attractive for big industrial application, right? We will see some features in few slides. Some points to highlight here. All of them are compatible with bifacial models, bifacial or high, I would say even more next generation models. We will see on a slide about this. Bifacial or high power models, right? With the high efficiency models that comes more or less, or nowadays, sorry, with more than 30, 14 amps per string, right? So we have all the portfolio ready for the new models that are already in the market. And we mentioned here optional is because we have a specific models for bifacial. And then you see here that with the input of the portfolio is not 1,000, what is quite common in the market is 1100 volts, what allow us to make bigger or larger strings in the PV side. We will see a slide what the benefit of this input. And regarding the MPP trackers and the strings, we mentioned here also, good to mention that our portfolio, most of them is fuse free. That means that we design and build our products, our inverters, with two inputs per MPP tracker. That means that we don't need to protect by fuse the string, the MPP tracker, right? In this case, the 25 kilowatt model, there are 3 inputs in the first MPP tracker, so that would be require external protection. But in general, you can see it's fuse free, or in the empty case, it's already integrated. So more in detail, let's have a look some features, key feature of the C&I. What we are going to mention is not only for the HT, it's across the portfolio. So coming from the SDT generation 2 up to HT series, the multi-MPP tracker allow us to optimize the PV array of the inverter, of the PV system. We have here some pictures. It's clear about the different tilt and azimuth. This is quite clear in this example. This is a ground mount. Quite impressive, I would say. This way of building. It's not my way, to be honest, but this is quite impressive how they use the hill, right, to combine to build the PV system, right? Of course, it's mandatory to use here. I would say that would be required to use a multi-MPP tracker string inverter to optimize the PV array. Because if you use one MPP tracker inverter, like a central inverter, the inverter will work not an optimal way, and for sure the PV modules along their life will suffer, for instance, about hotspot and other physical phenomena. That is not the topic of this presentation, but for sure, when we face different tilt and azimuth, we need to think from the design point of view to use a multi-MPP tracker inverter. This is a ground mount, but this is a quite common, is the common topic every day in the C&I. When we work in a commercial industrial, we are designing PV system on rooftops. That means that usually are not facing the south or the north if you are in the southern hemisphere. The tilt usually is 10, 12, or maybe flat, the rooftop. So that means that we need to look for how to optimize this rooftop, right? So it's quite common. It's very common actually in C&I in this situation, this scenario. Needless to explain about the dirt and the shading and also the some impacts and so on. Here a clear example of the shading, the impact. Of course, those modules are not going, or those one actually are not going to work in the same way. So by means of using an inverter with multi-MPP tracker technology, you will be able to optimize the available energy, no matter is the condition of the string and the PVR, right? And mismatch is quite common. This is quite common when we combine different PV cell or PV module technologies. With an inverter with a multi-MPP tracker technology, we can use different technology, but always keeping the same technology per MPP tracker. Another feature really relevant in our portfolio is the DC oversizing. In C&I, it's common. You can see here a picture, an example, that we need to optimize. First of all, we used to optimize the rooftop, right? So we can optimize the rooftop by means of an inverter with a high level of DC oversizing. In our case, our portfolio is up to 50% of the DC oversizing. And here is an example. For a given AC capacity, we can optimize, we can use more available surface by means of this feature, this capability of the inverter. The same concept, but in a different way, is that if we use the rooftop at maximum level, that means that we optimize the surface. That means that we compare a given DC power, right? We can reduce the number of inverters by means of this feature, the DC oversizing. And that is a positive impact in the CapEx. That means that by means of the DC oversizing feature of our inverter, we can reduce the number of inverters for a given DC power. And that means that our capital expenditure, the famous CapEx, will be lower than a situation that we have to use an inverter with a DC oversizing, also with a low DC oversizing level. This is quite common and very positive feature that our EPCs, our customer, likes, especially when they design C&I systems. The AC overloading allows the inverter to feed into the grid a bit more energy than the nominal one. Obviously, that depends, or that happens as long as we have enough energy in our input. And that is combined with the previous feature that we have seen, the DC oversizing. So the combination of those two features can make us to feed more energy than the nominal one to the grid. Of course, if there is a legal requirement that we cannot provide more than the nominal one, we can set up properly during the commissioning the 100% of the energy in the settings of the inverter, right? And this feature, this slide, sorry, is the thermodynamic behavior of the inverter. And for me, probably is one, in my opinion, my experience, this is one of the most important slides to understand. If we understand the last two slides in combination of this one, we will be able to select the proper inverter for our project, no matter if it's a C&I, no matter if it's a residential or utility. The rewriting that everybody, I guess that everybody knows, is the firmware, is the algorithm that the inverter use, or we introduce in the inverter, we design this way to control the input power and therefore the heat in the inside of the inverter to avoid precisely overheating inside of the inverter. The most critical element in an inverter is the IGBTs, is the transistor. Isolated gate bipolar transistor is the acronym of the IGBTs, and it's very sensitive for a high temperature. Of course, you see here the ambient temperature. You can imagine that the temperature inside of the inverter is higher. So we need to protect the temperature inside of the inverter. We need to protect the IGBTs, the transistor, not only the transistor, but the most important one is the transistor, to keep the life of the inverter, first of all, as expected, and second, to optimize the conversion from the DC to the AC side, right? That means the performance of the inverter. So the way that the inverter manufacturer has to control and to keep the IGBTs in a good state, a good shape, is by means of controlling the input of the inverter. And that's why we need to control, to sensorize the inverter, as we do, to monitor the inner temperature, and that means that we can estimate the heat inside of the inverter. Then by means of this algorithm, the rating, we can control the input. The temperature, there is a threshold for every inverter manufacturer who define when the inverter has to change the input or the operating input of the PV array, and therefore to reduce the power, the output power. That means that let's give you an example. If we get in the input a number of current, a high current moment, because there is a very good moment, the inverter could be eventually overheated. So the inverter will apply this algorithm to reduce the output power. That means that will reduce the input of the inverter. The limit depends on the inverter manufacturer, depends on the design. In our case, for the C&I portfolio, the threshold is 45 Celsius degree ambient temperature. And this is very significant because in our competitors, you can see that really relevant competitors, the threshold is 20 Celsius degrees. And let me highlight here that we are not talking about 100% of the output. This is the output power of the inverter. You see here the 110%. So that means that let me come back to the previous slide. We are considering this scenario that also is related with this scenario. So the DC oversizing, the AC overloading, and the rating is linked somehow. That means that the good news for us is that GoodWe design and produce the inverters considering the derating for the full load operation. And that full load operation, that is a very important concept because we are talking about this DC oversizing feature up to 50%, and that AC overloading feature that we are mentioning up to 10% of the portfolio. So in that scenario, full load, what for us is full load, so maximum capacity of the inverter will be able to work in this condition, right? Above this temperature, of course, the inverter will keep the control of the input to keep a good operation behavior of the components, especially the IGBTs. I include here the CI portfolio is 45, but we have the model 50, the MT50 kilowatt, that the rating is up to 50 kilowatt. This is really important for very hot areas. I'm sure that in EMEA region, you are able to identify some areas that will be very useful. This not only 45, but the 50 Celsius degrees. Regarding the new, what I call new generation modules, you see here two examples, the bifacial models that are common more often in ground mount, etc., and also the high power modules. We don't pretend to promote any brand, but what we try to highlight the current that we see already in the market. And I would say that this is not the latest one. I think we have already in the market the models above 600 watts, which means that the current will be a bit higher. In any case, the high power modules is around between 12 amps and a half up to 14, 15 amps. The bifacial modules are more or less the same, around 13 amps, I would say. And here the relevant thing is that our portfolio, as I mentioned before in the resume, can operate with these new generation modules. And let me open a bracket here. All the inverters, generally the market, could eventually operate high power modules and bifacial modules, right? No matters what they say in the label. The point is that the inverter will cut the input. That means that we'll use the available current depending of the design of the inverter, right? What means that an inverter who is not equipped with the proper components will get only the maximum capacity of the inverter per string, not the maximum capacity that the PV string could be provided. And that is very important, because we need to pay attention that the inverter, when we design and we are selecting the inverter for our PV system, has to be equipped at component level with components precisely to be able to work with high power modules, high current. In our case, the HT, and also we have seen before in the resume, our portfolio is ready, is compatible with this kind of new modules that we have in the market. That means that the inverter will be able to get the maximum energy, the maximum performance of the PV strings, because the inverter has been designed at component level to be to work with this kind of new modules. I'm going to go faster here. I think everybody knows here that more or less in the market we work with 1000 volts, and we work in the C&I portfolio 1100 volts, right? So that means that we can increase the number of modules in the per string. In case of our inverter 250 that operate with 1500 volts, of course we can make larger the string, and that gives us the chance to lower our investment in the DC cabling, and sometimes in the racking system as well, depending on the model that we use. Protections is also relevant, very relevant actually nowadays. Sometimes we see in the market that the inverters are equipped with a DC side and AC side with some defined protection, defined by the manufacturer. In our case, we protect not only the AC side and the DC side, we protect also the communication. Regarding the AC and DC side, depending on the model, we have type 2 or type 3. And in the communication, we protect with SPD type 3. And we protect the communication board, what is relevant, to be honest, in all the portfolio. I'm not sure about the other brands, to be honest. I know that few of them don't protect the communication board. And the communication board is also sensitive to over voltage, especially through the communication lines. In any case, we protect the inverters, you can see in the DC side and AC side, type 2, type 3, depending on the model, and communication board type 3. Like an option, we offer the PID-Recovery solution. For those who are not aware about the PID, it's a physical phenomenon. It's a potential induced degradation of the PV module. This physical phenomenon may happen, may occur, depending mainly on 3 factors: the quality of the module, the humidity of the location, and also the length of the string. It's larger, more probability of, in combination with humidity and the quality of the module, of developing this physical phenomenon. We have a solution to revert the PID phenomenon. This phenomenon basically degrade the modules by a leakage current, a really tiny leakage current from the most negative cells and most negative modules to the earth. And the solution that we provide, that also is common in the market, we provide a reverse solution, a solution to revert this phenomenon that operates during the night. Can be applied in a retrofit way. So, but in any case, if you are thinking in a PV plant or designing a PV line with no really, if you are not sure, let's say that you are not sure about the quality of the modules and you're sure that the location is shows a very high humidity level, you should consider, at least in the design point of view, to add the PID solution. Remote diagnosis and remote shutdown. Actually, this is also more and more common, and not only in utility, but also in more and more in C&I. We can control the inverter remotely, of course, and also with the remote shutdown that is more common, especially in the depending of the scenario. But with the facility that we are designing the PV plant, it's a public facility, or let's say a critical activity like a petrochemical activity and so on. Usually they require a remote shutdown to stop the PV plant, and we have this solution, of course, in our portfolio. Another option is the AC connector temperature detection. I have to say, first of all, sorry, because this picture is for the DC side, but this we keep it here. We know that it's wrong, is the DC side, and we have mentioned we highlight here the AC connector. This picture, we keep this picture actually because this is a clear effect, a clear vision of what a wrong installation or maybe the wrong quality or bad quality of the modules can affect us, right, in a PV system, right? So it's important to keep the control for sure, good quality products, a good installation, etc. But also, if we can monitor the PV system in that level, we will get more information remotely about how our system performs, including the protection level, right? In this case, this proposal, this offer, or this option that we offer you is the AC connector temperature detection. What control in the AC side, how is the temperature of the connectors, and sometimes the torque is not properly done, etc. So we can avoid future issues like what we see here in the picture, right? And this is why we keep the picture, right? To keep in mind the potential effects of not attending properly the operation of the PV plant. In the same way, but this is in a DC side, we have this protection like an option that is in compliance with this and the UL, the written laboratories. This is the US standard, probably the most difficult standard to achieve and to pass. And our protection for the arc failure, it's already in compliance with this standard. We have equivalent for Europe, but let's say that in US it's more sophisticated and more relevant to pass this standard because, let's say, there are more wooden-made facilities, etc., and it requires a really specific caring of this topic, right? Basically, this protection works in the way that if someone open and not intentionally, or maybe yes, who knows, the DC circuit under operation, of course, there will be an arc, and the inverter will be able to detect this arc and stop the inverter, this MPP tracker, immediately to protect not only that person, but also the installation, right? So this is something relevant for those C&I projects that maybe you are thinking on, or you are designing a wooden made or where the protection, this kind of protection is a requirement from the tender or from the owner. This slide is something quite new in our presentation. We introduce now, at least from my side. This is a software. Sometimes when we are talking about not only C&I in a rooftop, but sometimes C&I also refers to agriculture, for instance, right? And depending on the legislation, depending on the norms in the country, there are some more additional restriction in terms of the residual current breaker, the RCD, to install in the PV plant, usually up to 300 milliamps. So we developed it, our colleagues in R&D developed a special software that apply for the C&I up to 60 kilowatt. That means that the SMT and MT are suitable with this new software to keep the control of the inverter to avoid higher residual current. That means that we can install one RCD up to 60 kilowatt, when in the market usually you find that you have to be limited by this restriction with inverters with up to 30 kilowatt, right? So it's quite relevant, especially for this kind of application. That is also, in my opinion, belongs to the C&I, right? It's a subsegment of the commercial and industrial portfolio. And finally, the flexible monitoring solution, before coming to the commissioning step. We can monitor in all the portfolio in a single way. I mean, if we are commissioning one inverter, we can monitor the inverter with a Wi-Fi module, Wi-Fi communication that we connect to the existing router, or by means of the 4G module that we connect, obviously, with the communication operator in our country. This is for single unit. For multiple units, we can use the traditional RS485 or the PLC. PLC is quite common in the utility scale projects, ground mount, etc. But also it's available in the C&I portfolio, SMT and MT and HT for sure, for commercial and industrial. In some cases, in a really specific cases, has been considered PLC also to communicate in a commercial application. I have to say that it's not common because the number of noise that you can get because due to the activity of the facility. But in any case, it's a technology that you have here available for the C&I segment. The traditional one is based on the 485, traditional technology. And we have the ZLogger Pro and the CC1000. We are going to spend a bit more time here in the next slide about the CC1000, as well as the Wi-Fi module. For the PLC is the CB3000 that allows us to communicate, even to use the optical fiber. But this is something that we can have a look later on. And the compatibility, this is something also relevant for, especially for the big EPCs and tenders and owners that usually requires compatibility with SCADA. All the monitoring portfolio is in compliance with the international standard AIC 60870, 60870, I think. That is the standard to communicate machine to machine, basically, what allows us to communicate with the existing SCADA in the facility, right? Of course, we can add a weather station or like a third-party monitoring devices, etc. Also by means of Modbus RTU. So in this point, we finished this C&I portfolio and key features. I know that has been a bit tough. Now we are going to, I hope that we will be in the next chapter easier and more easygoing, let's say that. For the commissioning, let me start with I don't pretend to stop here so much time because I think all of you know everything about this. But in any case, let me highlight here a couple of slides that we think that are important enough for all of you. What we need when we are going to do the commission and the preliminary info, for sure, get familiar, please, with the manual. We have seen many times that many installers, especially during the installation, not during the commission, but during the installation, they don't follow the instruction. And you have there the instruction in multiple language. The apps that we have, SolarGo, PV Master, and SEMS app, or SEMS portal as well. You will need, of course, during the installation, the tool set, whatever you need during your installation, and the the digital multimeter and amp clamp. I personally recommend also an amp clamp because you can during the commission you can check under operation the PV system, and it's very useful to identify potential mistakes or errors, etc. And of course, the personal protective equipment following the local regulation. We need to keep in mind that we have two types independent type of settings. Internet setting and grid or country code setting are completely independent. That means that we can do properly the grid and forget the internet one. And of course, we will not get the monitoring. So we need to do both properly during the commissioning. The SolarGo, we will use now the SolarGo That is the app that we need to set up, we need to use for setting up the commercial and residential portfolio. The PV Master is for the the energy storage, hybrid and retrofit families. And the SEMS app is the portable version of our SEMS portal, the same platform. So in this case, we are going to use, in the next slide, SolarGo and also the SEMS portal, the SEMS app. Nothing to mention here. This is during the installation, you see that in the package of the inverter, you have everything. The only thing that is not included is the upper level monitoring solution like SEC 1000 or Data Logger Pro, our data logger, right? Everything is included further than this. For instance, the communication module, Wi-Fi for you, whatever you require. Inverter location, all the portfolio is IP65, but it doesn't mean that the IP65 protects against everything. Let me here give you an example. Snow. I mean, the IP65 doesn't give you this such protection, right, of snow. So we need to, in order to keep the lifespan of the inverter longer and longer, we need to pay attention about the location where we are going to install the inverter. Same for the proper wall or proper location or racking system where we are going to install physically speaking, the inverter, especially when we have obstacles or we are going to install different inverters. Because if we don't keep the clearance of that is included in the manual, the cooling system can be affected. And this is something relevant, and we need to pay attention about this. The heat of one inverter could influence the second one, etc. So we need to keep the distance that is included in every manual to ensure that the cooling system, and also we mentioned before that the rating will not be affected by this kind of physical phenomena, actually, right? The heat from one inverter or the obstacles to avoid the proper airflow will impact in our inverter. Racking system, just only to mention in the manual that we have, in the manual we describe in every specific model the breaker that is required. So this is an example as the SDT Gen2. Actually, this is the smallest C&I inverter that we have seen in the resume. So what we highlight here that in the manual, please get familiar with it. You will get all this information. Same for the DC connectors, of course, and the potential earth connection. That is, what can I say? It's mandatory to, from the protection point of view, and also from the operation point of view, the inverter and also the mass of all the PV array has to be connected to the same ground. So please pay attention about this. And here, finally, the remote shutdown that we mentioned before. In some inverter like XS, is a residential one, but SDT Generation 2 and SMT, that is commercial and industrial inverter. There is a communication terminal that is equipped with a bridge. That means that we want to install a remote shutdown, the external circuit that we have mentioned before. We need to remove this bridge and install the shutdown circuit, right, to control this inverter and the change of the inverters. If we are not interested to install this external remote shutdown circuit, we need anyway to insert this terminal that is equipped in the inverter in the package. So we need to ensure that this terminal with the bridge is connected properly to the inverter. Same for the MT series that is included inside. This is a 4-pin terminal, and we need to ensure that this terminal is properly connected in the inverter. And then once we have seen already briefly the installation tips, let's say that. Let's go with the commissioning. And before the commissioning, we like to show this slide because we have seen during the last year when we have been preparing the GoodWe Plus program, etc., and this kind of presentation, that the installation, and also based on our experience after sales, the installation of the inverters, etc., has been done by a different team from the commissioning one. That means that there are maybe it's two teams, or maybe it's a team for the installation and one guy for the commissioning and so on. But eventually what I try to highlight here is that person or that team that will be responsible of providing to carry out the commissioning has to be ensured that the installation has been done properly. And that is very important also to highlight the manual and all the slides that we have seen previously, right? To check the polarity, the voltage has to be consistent, depending on the number of modules that has been designed, this PV plant, the installation. Maybe there is an error in the installation of the modules, etc., in the combination, the AC connector, and so on. And then, of course, the terminal communication. And then once we have checked all these tips, all these points, we start the commissioning. And then we will avoid different topics, different potential issues, right, on the PV system. Then we start and we go ahead with the internet setup. The internet setup is very easy, very simple. We turn on the DC switch of the inverter. Every inverter is equipped at least with one DC switch. That means that by means of the DC side, the hardware of the inverter is supplied. So we don't need the AC side so far, only the DC side. With our smartphone, in a distance no bigger than 5 meters, we open the setting of our smartphone and look for the Wi-Fi networks. And we will identify solar Wi-Fi, followed by the 8 digital number of the serial number. That helps us a lot, actually, when we are commissioning different inverters. Especially in C&I, we are usually carry out commissioning of multiple inverters, right? So in this way, it's very simple, very easy to identify to which inverter we are communicating, right? By means of our smartphone. Then we identify the solar Wi-Fi, we input the password, you see here from 1 to 8, and we open, in this case, SEMS app. No need to enter in the app, just only to click in Wi-Fi configuration, to click next. That is the screen to confirm that the inverter is powered on, of course. And then we identify the router name and the password. We click, and then we almost finish. Let's see, we will see into a slide what means observe the LED. This is as you can see, it's very simple, right? Open the smartphone, the settings, identify the serial number with solar Wi-Fi, etc. Open the SEMS, identify the router, input the password of the router, existing router, and that's almost all. If we can use also the browser of our laptop, pretty the same, close distance to the inverter. We will open our internet access in our laptop, identify the same way the solar Wi-Fi, and then we will open our browser. In this case, we put this address that is very simple to keep in mind, 10.10.100.253, and a simple way of admin. I mean, you have all this information in the manuals, so don't worry. You can follow anytime. No need to learn by heart this thing in this presentation, of course not. And then we open the browser. We follow the steps of the browser, and this step is very is relevant also for us, because in this step, what we see here is the network, the Wi-Fi networks that our inverter, our Wi-Fi module of our inverter is detecting at that moment. So, and that column RSSI is the strength of that network that inverter detect, that Wi-Fi network provided by our router, the router of our customer, the router of our neighbor, etc. Of course, we need to click on the one that is our customer, but the relevant thing here is that this column, that is the strength, give us how good is the Wi-Fi network in the location of where the inverter is installed, right, where it's located. If the value is below 50, we recommend, first of all, to relocate the router. Sometimes it's not possible. In that case, second could be the second option could be the install an amplifier of the Wi-Fi network by means of those devices that you can find in the market. 20, 30 euros actually is the price in the market that extend the Wi-Fi network the existing router, right? So if that is not possible, you can always consider to change to the LAN module. That also we have the chance. But this is something relevant because you have here the way to confirm how good is the Wi-Fi network created by the router. And this is relevant. And then the next step is to input the password of the router and then observe the LED. What means that? In all our inverters, no matter if the inverter is equipped with a display LCD screen or not, all of them are equipped with LED. And you see here on the left side the meaning of the LED, right? No matter this is a residential, this is the XS series, and this is the hybrid series, the EH series, an example. The same for the commercial industry, the same for the utility scale product. We need to confirm once we finish these simple steps that we have seen right now about the internet connection, that the inverter is connected properly with the router and the router to the server. And the way is by means of observing the information that is provided by the LED. Once it's solid, that means that the internet setting has been done properly. Commissioning setup, the grid setup. First of all, let's view a brief intro of what we are going to see in the inverter. The front side, we have, as I already mentioned, in the left side, the LED status info, right? The meaning of each status. In the right side, the technical parameters of that model of the inverter, and the serial number and check code that we will need to add this inverter to the PV plant in SEMS portal. This is the example of the generation 2 with LCD or without. Model from 17 to 25 kilowatt. Here is the 25 kilowatt. You see here 3 inputs in the first MPP tracker and two inputs in the second MPP tracker. I don't pretend to stop here so much time. Let me clarify here that our architecture, how we build our inverters, is always the same in the not only in the residential, also in the commercial, and of course in the utility scale. In the left side, in the bottom, if you see the inverter in the bottom side, the left side is always the DC input, the PV string are connected here, the DC switch. In the right side, the AC terminal, the AC output, and in the middle, let's say that, the communication part, Wi-Fi, 485, etc. Depending on the model, we will see here the cooling system, the fans for the cooling system. SMT with LCD, we will have a look at an example, and without LCD as well. You see the same structure, coming the fans coming from the right to the left. Actually, let's stop here, and because I wanted to show you a real case. Give me 1 second. I think Oricia, sorry, you have to transfer the view, right?
Yeah, we cannot see you right now, but if you turn on the second camera, it should be fine. Let's check. Okay, yeah, now we can see you. Mm-hmm.
I'm coming. Huh? I wanted to show you here live. We are in the office in GoodWe Europe in Munich. Let me turn. I think it's much better to see. This is the real SMT. In the left side, you can see the LED status. There is no LCD here, everything is with LED. And here you see the technical parameters and the fans in the right side. The airflow goes from the right to the left side in this model. You see here the input, 2 string per MPP tracker, right? 2. So we have the SMT, remember, is 3 MPP trackers inverter. We have here the DC switch and the Wi-Fi module. So
we can remove, etc. And here is the AC output. You can see here also the port for the 485, right? So this is a real example of the SMT. I'm sorry, we don't have here MT, but here we have different models, right? In the same way, this is an hybrid inverter. The DC side, Wi-Fi, and AC output. We have two AC outputs because the hybrid is equipped with two AC output. So let me, sorry, like this. Let me come back. I will show you later on.
Yeah, now we can see the presentation, so it should be fine, but we cannot hear you. So please remember to turn on the micro.
Yes, I'm here, I'm coming back. So I hope that you could see properly the inverter. We thought that was nice to show you an inverter, not only slides and drawings. So this is SMT. This is what we have seen, actually. That is the model that we have seen with a LED, no LCD. MT, the same left side. This is the with up to four MPP trackers. You have to 4 stream per MPP tracker, and that model or that series MT, as you remember in the resume, is equipped with fuses in here in the bottom side. It's the only one model that is not fuse free, but we add the fuses, the protection in the bottom side. And the HT. That is a new inverter, not so new actually, but in this year we introduced to the main market. Left side, in the right side is the AC terminal. In this case with the display. So if we, as you can see, the display, the tendency in the market is a 2-line display or 2-line LCD. We are going to do an example with the grid setup by means of through the button on the LCD. In this case, this example is the SDT generation 2, but you can see is the same for the HT if we order the inverter with the LCD option. We turn on the DC switch and also the AC side. Actually, there is a mistake here. DC and AC switch. We are going to use the button, right? The GoodWe button to enter to confirm each field that we will see. The menu is very simple. You have everything in the manual. Let me remind this. But depending on the model, the menu is bigger or shorter. Obviously, depending on we are talking about residential or SDT generation 2 or HT. In any case, the C&I is pretty the same. Once we turn on the DC and AC switch, sorry, here it's written here. We will see this screen, the home screen. Normal is 2 lines. The second line is always the same. Is the output power of the inverter. During the commissioning, obviously, will be 0 here. Probably a waiting, or if the AC side is not has not been connected, will be a message that is not being connected. But in any case, the second line will be a permanent information of the status on the inverter. The first line is in which point of the menu, which point of information you are, right? So we start with normal. By means of a short press of the button or long press of the button, we are going to change the menu and the level of the menu. The first level or second level of the menu. In normal, with a long press, we can access the grid code sub-menu, and then we will be able, by means of short press, to select the country. In this case, for instance, Poland, right? Once we select the field, in this case, the country where we are, that we want to set up, we release the button, no need to do anything, not to do anything additional. And then the inverter will get the last information that you have been selected, right? So the same way we come back to the home screen by default. And then we select the language, we select the set time, etc. Right? So it's very simple. It takes 2-3 minutes to do the setup of an inverter. As long as we are talking about the C&I, we can set up the inverter depending on the grid that we are connected, as star or delta. So we select the menu grid type, a long press, we include the password. This is a second for protection, for safety, sorry. Second level menu. And then we will be able to select a star or delta. Remember that inverters, all the C&I can operate with or without neutral. That is also a help to reduce the investment in the cabling. Neutral could be even 25% of the cost of the AC cabling installation, right? So usually it's a star, but depending on the market, depending on the grid that we are working, depending on the facility, of course, we need to confirm if the inverter will work in a star grid or a delta grid. And basically, that is all that we need to do in the grid setup. As you can see, it's very, very simple. This is by means of LCD. If we are talking about the SMT that we have seen, we have seen one without LCD that we are. I don't pretend to stop so much here because basically the menu is even easier. By means of up and down buttons and enter and escape buttons, you can confirm and flow up data language, the date, country code the same. You access the country. If you don't find your country, you can set up always the 50 Earth or 60 Earth default grid, depending of the region. And in advance, as we have seen, a power limit or grid type, delta and star. Basically, the logic of the menu is the same. You see here that the advanced settings are more sophisticated. So you have all the information in the manual. But with these basic steps, you will successfully set up the inverter for the grid parameters. Now we are going to do the same with SolarGo. That more and more often it's the trend in the market, right? They're trying to use SolarGo. That means to order inverters without LCD, and we do the setup through our smartphone. We turn on the DC switch and the DC switch just to connect the smartphone, right? The SolarGo is the same step as before, but we are going to use the SolarGo, right? Let me jump here because I'm going to show you here this screenshot. This screenshot was taken by myself. Was the the first 80 kilowatt model of the MT series with PLC. Was of the first one in Europe. And we did the commissioning. I did the commissioning in October 2019 in the south of Spain. You can imagine by my accent, I'm Spanish. So this is a real case of a commissioning of an inverter. We have here the SolarGo, the serial number, the energy flow chart, and some general total values. In parameters, you can identify in this screen all the electrical values that the inverter are under operation. I mean, that inverter is working on. The DC, the first MPP tracker, the DC voltage and the current of the MPP tracker, etc. And then you have the AC parameters, so AC values, and then a string level. The version, the firmware version, etc., and then the settings. So this is something that we want to do now because we are doing the commissioning, the first time of the commissioning of the inverter, right? So in system parameters, we can set up the time. In grid connection parameters, we have to select the country. In this case, as I mentioned, was in Spain. This real case, and the connection, the selection of the grid. In this case, there is a second screen, and we can select the type of grid with or without neutral, right? And then it has been finished. You can see in SolarGo there are more. The menu of the SolarGo is bigger, of course. with all these few steps, it's enough to set up the country code. If you need more parameters like a power limit function and so on, you can do it also here in this in the operating parameters that is not included in this slide, but it's a very simple step. So far, we have seen the internet and the grid code setup for one inverter. Let me show you here a case study. This is another example, real in Portugal. It's a chemical factory. It's close to the sea, actually. They produce the activity of these companies. What they produce, chemical product to facilitate, right? The agriculture, the vegetable and fruit production, etc. Right? So it's a pure chemical or the chemical industry. It's 300 kilowatt nominal power with 560 kilowatt empty models and one SEC 1000 unit to control, as you will see now, this PV plant. This scenario is quite common. What we saw in that facility is that it's very common in commercial, especially in industrial, like the case scenario, right? The reactive power capacitor banks. Usually, we will see this kind of solutions to compensate the reactive power in the facility. What means that the quality of the grid inside of the facility is not the ideal one, right? So, and that is an impact, because if the quality of the grid in the facility is not good enough, the inverter or inverters could be affected in the way that when they try to connect to the grid, to feed into the grid, if the parameters that they are monitoring, the grid parameters that the inverter monitors permanently are out of the range, the inverter will wait until the grid is more stable, right? So this situation is quite common, especially in industrial, less in commercial, but more for sure quite common in industrial. This is something that we need to consider when we design a PV plant in this kind of a scenario, right? In this kind of facilities. Our solution is the SEC 1000. Let me introduce here this solution. It's a device that gives us a lot of possibilities in this kind of scenario. For instance, to monitor up to 60 inverters. And I have to say that not necessarily the same inverters. We can combine SDT generation 2 with different models, with MT or different SMTs, etc. As long as all of them communicate with 485, that I have to say, yes, all of them communicate with 485. So we can combine all the commercial and industrial inverter portfolio, GoodWe, with one device, up to 60 inverters, right? And we do it by 485 communication line. We can limit the export power of the PV plant to the grid, right? Here is a basic example. Obviously, it's a three-phase application. This is only a explanatory diagram, obviously. But by means of these CTs, that is current transformer, the SEC 1000 will control the import and export power flow. So with this device, we will be able to control the export power to the main grid, right? So in some cases, some markets, depend on the norm of the legislation, is not allowed to export energy or an amount of energy to the grid. So this device gives us this function as well. Load monitoring, of course, everything. We have this information, so we can monitor the load, existing load in the facility. As we have seen, reactive power control, also this device can give us this input in the inverters, and we can provide a massive update of firmware locally in the SEC 1000 or remotely, what is also very interesting for O&M task, right? It's IP65 with an AC switch included, but let me show you a real SEC 1000. 1 second.
I try to connect the camera. Mauricio, can you give me?
Yes, you should be able right now. Ask to start video. I'm not sure if this device is on,
Yes.
but it should be fine
okay,
now.
already. And here you have the SEC 1000. You have here the AC breaker. We come here with the three lines on neutral. With this, we feed the device, the internal communication, the three-phase meter. We get the voltage here, and we get the current information from the external CT, the external current transformer that we will see in the slide right now. We connect here the three current transformers. Then we get information of the current transformer to the meter and the internal board. And here we have the SETA logger design. The SETA logger Pro is our data logger. Actually, you can see here the ports, the Ethernet port that goes to the existing router of the facility. The three ports that communicate with inverters. There are 3 lines. Each line can get up to 20 inverters per line. So that means that we can control up to 60 inverters. And here goes to the meter. And here we have a USB for the firmware upgrade and the reset button as well. So basically, this is the SEC 1000 that you see. Basically, just to give you. This is the size on my hand. You see here the site IP65 cover, so you can install indoor, outdoor. Please protect as much as possible the devices. And then let's come back to the presentation.
So we have seen the real SEC 1000. And let's have a look about well, this is the part that we have seen already, so no need to stop here. But the cities, this is important to highlight here. Probably the most important thing, when we apply this solution, the SEC 1000, we need to pay attention carefully about the selection of the current transformer. The current transformer is X/5. That means the X is the primary. We need to select first of all, we need to select the current transformer, the type of current transformer based on the electrical installation in the facility. If it's a bus bar or wiring, right? It's not the same. Here could be applied for both, right? In this example. The primary has to be suitable for the maximum current, as we mentioned here, of the installation, including the PV, but not only PV, right? So it has to measure everything. And the secondary has to be 5 amps, because this is what the SEC 1000 can read, right? It's the standard one, by the way. We recommend open core CTs. Basically, open core means that you can dismount this part of the CT and build again once you insert the main body in the bus bar or in the wiring. That gives you the chance to install the CT without any intervention in the electrical facility, right? Otherwise, if you use a closed core CT, you need to dismount the existing electrical cabling and bus bar, etc. What is not really recommended. That's not very smart. So this is an example, explanatory diagram, right? So the most important thing in the CTs is the location and the direction of the measurement, right? So you need to be sure that the location has to be upstream of the consumption and also of the PV system. Has to read import export to the grid, right? That is one of the most critical things. The software, what do we need to set up the SEC 1000, you can find it in google.com. Download software here. You have the SETA Logger Pro and the SEC 1000 is the same software, because basically the core of the SEC 1000 is the SETA Logger Pro, right? You open your port in your laptop, this is only one step actually. When you click here in properties, you will get this screen, and then by clicking in following IP address, and you set up the proper address to communicate with the router. So it's something that we are usually familiar with this when we connect to the office in the network, etc. So this is something that's quite common. And then we open the ProMate. This is the home screen in the ProMate. There is only one screen, right? So we have the English version. In this part, well, let me first say that we have English version, and in this screen we will see what we have done, or every step that we do here in ProMate. That means that if something is successfully done, will be recorded here. But if something is wrong, will be recorded here as well. So we can track our actions here. The second point is to confirm that the connection with the ZLogger Pro, with the SEC1000, has been successfully done. The serial number of our device, you see here, SEC1000. The software version of the SEC1000, this version is the ProMate, right? And the third part is to input the communication line that we use in the to connect with the inverters and the number of inverters. We can refresh, and we will see here a list of inverters. In this case, there is only one, and it's online. If it's offline or is missing, for sure this abnormality is related with the line 485. So it's a very good tip to check the line 485 or S45 if the inverter is missing here or is offline. In this case, just almost at the end of this setting up, in this box, we have to input the total capacity of the PV system, and the power limit in this case is above the limit, so we input 60. And the rating of the CT is also relevant. We have here an example. If we use, for instance, a 250 amps in the primary circuit, also coil, and 5 amps by default in the secondary, actually the result is 50. This is what we need to input here, right? Once we input properly, we set, and we can, once we do this properly, we get data, and then a hidden information pop up, and then we can check actually how is the import-export reading of our cities. This is a real-time data. So let me give you here a tip. If we switch off the DC side, that means, and there is no other PV system or any other energy generator in the facility, that means that all the energy is coming from the grid. So we are importing energy. What we have here in that scenario is negative. What means that is current? Negative means for the SEC1000 that is we import energy. In this case, we are importing 2.8 or 2.9 kilowatt in the phase number 1. This is the phase number 2, in the third phase, etc. So if we see here a positive value when the PV system is off, that means that the CT is not reading properly. Probably we need to change the direction of the reading of the CT, of that CT. So it's a very good point to check, right? These kind of things. And eventually the last thing is the IP. We can select the dynamic IP by clicking here, or we can set up a static IP. And then when we finish, we connect our ZLogger Pro to the existing router by means of the Ethernet line. And then we observe after a few seconds if the servlet is on, blinking, or off. If it's on, the communication has been done successfully. If it's blinking, something fails, probably the IP. And if off, we need to check all the steps that we have done because something is run. Of course, don't forget to add the SEC1000 to the PV plant on SEMS. Otherwise, we cannot monitor the load monitoring, we cannot monitor the inverters, etc., etc. So we need to add the inverters and the SEC1000 in our PV plant. If we see in our portal, in the SEMS portals, occur like that, we can say that something is wrong. And here, for sure, is related with the CTs. So we need to check maybe the location, probably the location, and the direction of the the cities. Because the normal view is like this. And if we see something like that, in blue is the PV, in yellow is the meter. That means is the in negative below zero is we are importing, we are buying energy from the grid, and in positive we are exporting to the grid. Obviously, in this plant we can export to the grid, right? And this violet line, it's the load monitoring, how our load consumption is showing in the portal. So basically, we are finished almost the SEMS portal. Basically, this is the home screen of the SEMS portal. You have here this information on multiple language. Maybe I like to mention here that maybe we work maybe in South Africa, and you select English, or in Portugal, Portuguese, etc. But maybe your owner, your customer, the owner of the PV system, is a British guy living in Portugal. I mentioned this because it's a real case that we have had in GoodWe. And this is very helpful to show also to the owner and our customer that the portal is in multiple language, that maybe it's more easier for them to follow in a different language if they are not locals, right? So we have here also the operation guide. We are improving this manual of the SEMS portal, and demos. In demos, you will see real system, residential mainly and hybrid, and very soon we will add some C&I demos plans for your knowledge as well, right? Login, and please, if you are an installer or EPC, contact your distributor or contact us, contact your GoodWe sales representative to get your SEMS installer account, because this registration is for the end user. And the architecture of the portal split the rights of access depending of the type of account. So if you are an installer or IPC or a company who install, etc., PV, please contact your distributor or the GoodWe sales representative to get your proper SEMS account. Once we access, we will see in this PV plant homepage the picture that we can change, the date when we created the PV plant, the location, the type of system, the total icons depend how we set up our PV plant, the feed-in tariff, etc. This is the graph of the system. That means that if there is only one inverter, we will see here the inverter. But if we are talking about a C&I of 60 inverters, we will see here one PV line. That is the aggregation of 60 inverters, right? So this is the system graph, PV, load, meter, etc. And here we have the information device by device. And this is very also very relevant because we have what I call operating information, not only the serial number, but also the real, let's say real time is 2-3 minutes delay of the data. The data is getting refreshing every 2-3 minutes in this panel, in this information, in this panel. We have here the power, the output power, the voltage, the frequency, of course, the DC input, outstream MPP tracker level, etc. If we add the CC1000, we will have here also put the CT ratio, etc. If it's online or not, etc. Right, and the firmware version of the CC1000, right. And here we have something also interesting for the O&M. If we click here, we will get the curve data, not of the system, but of this inverter. And this is very relevant because we have a lot of options to select. I mentioned here too, because I find it quite relevant for O&M. If we select IPv1, is the first MPP tracker of this inverter. And we are talking about the MT. That means that there are 4 MPP trackers. This is why we can select here 4. And this is the current, the output current of the first MPP tracker, right? In that date. But we can go scroll down and we select per string, right? Current per string in the first MPP tracker. And then we get the same current view, but per string. And we can activate and deactivate each string to see how evolve or to observe if there is something abnormal. And this is something that we can do remotely and helps a lot for the O&M teams to monitor how is the performance of the PV plant per inverter, and not only per inverter, per string at the string level, what is very, very, very useful. And finally, the SEMS portal has given us also the chance to set up the dashboard. Is a main panel that you can select all the PV plants, all your PV plants that you monitor in a list or in different boxes, or highlighting in a different box the saving, the PV energy generated, the self-consumption ratio, etc., or showing the picture of each PV system. And we already get to the end of this webinar. Thank you very much. I think it has been quite tough and quite complete. I hope that you enjoyed. I hope you get relevant information for your business, and we are at your disposal. Thank you.
Thank you, Luis. Thanks, everyone. I would like just to remind that for everyone who has been registering and attended today's event, we will share the PowerPoint presentation, the PDF presentation, sorry, after the meeting, and also keep yours updated. You can always check the current webinars on our website, and we also encourage you to submit for our newsletter, where we inform about the most important events and upcoming webinars and technical training. Thank you, and see you soon.
Thank you. Bye.